Assalamualaikum and a very good day to Doctor. My name is Muhammad Harith bin SHAFIENGI and my matrix number is 2010211192.
My name is NURAFNAN SYAMIMI binti SAIDUN. Matric number 2010211243.
And my name is MUS'AB bin JOHARI and my matric number is 20102253.
Hi, my name is Muhammad Syarifuddin bin Muhammad NASHIR. My matric number is 2010233137.
So today we would like to present our PBL, which is a super heterodyne radio.
Okay, for the introduction, one of the most well-liked radio receiver types is the superheterodyne. They are better than other radio receivers in terms of selectivity, while having a more complicated RF circuit layout. They were developed in 1918 to address the problems of low selectivity and have dominated radio communication since then. Next slide. For the amplitude modulation, this is the process of converting an audio sound wave into a radio carrier wave of high frequency. The carrier wave's amplitude height is changed during transmission so that its peak conform to the contour of the audio wave.
Okay, next, Superheterodyne radio or superhet radio. The concept. The image response in a superheterodyne radio comes from the fact there are two frequencies. The first one is signal can combine with the local oscillator to give an output on the intermediate frequency. Second, the mixing process in the receiver causes signal that are either on the local oscillator frequency plus the IF or on the local oscillator frequency minus the IF to be converted down to the intermediate frequency. Okay. Additionally, the fact that the two signals that can be picked up are separated from one another by a frequency that is twice as high as the IF. Often, it helps to add some actual numbers to example to understand how it's play out. Okay. This is an example of superheterodyne receiver image. Is the twice the IF away from the wanted signal.
Okay, this is the block diagram of a superheterodyne radio. First, we have the antenna. Antenna will accept the electromagnetic wave. It will get the various type of frequency and it will process the electromagnetic wave, convert to electrical wave. And second, we have a radio frequency amplifier. The radio frequency amplifier is to select or tune the desired frequency. It will just accepting the specific frequency and reject all the another frequency. For example, it just want the 100 Hz frequency. Then it will amplify the weak signal. And then it will process the signal on the mixer block. The mixer block will convert the desired frequency into the medium frequency that known as an intermediate frequency with the help of the oscillator. This process, then the intermediate frequency amplifier. Intermediate intermediate frequency amplifier will amplify the using uh, the signal of the intermediate frequency. So we can increase the selectivity, sensitivity, and fidelity. After that, we have the detector or demulator. It will perform the process of demodulation modulator form, and from the signal it will detect the audio signal. And the last is audio frequency. Audio frequency will amplify the audio signal, then transmit the signal into the audio signal. And then we have a speaker. The speaker will convert the audio frequency into the sound wave. What is the actual transmit information? Okay, the difference between the carrier and oscillator. The carrier radio tune to a station is 800 K, and for the oscillator, the radio tune to a station at 1200 kHz. The carrier frequency is 800 carrier, and for oscillator, the carrier frequency is 1200 kHz. For oscillator frequency is 1255 kHz, and for the oscillator 100 355 kHz. The sum of the two for the carrier is 2055 kHz, and for the oscillator is 2855. And the difference of the the two is for a carrier is 555 kHz, and for the oscillator is 455 too.
Okay, so is the advantages of super heterodyne radio. First is able to receive multiple modes. Two, good adjacent channel selectivity. Third is able to receive very high frequency signals. And the fourth is a good sensitivity. The advantages of super heterodyne radio is image frequent problem and cost increase. Application of AM is amplitude modulation is used to improve transmission quality, offer high range broadcast, and avoid signal overlap. It has numerous applications, the majority of which are classified as electronic communication, which is two-way radios, broadcast transmissions, quadrature amplitude modulation, modems, and medium wave AM broadcasts as example of the application. So that's all from us. Thank you.